Salaam alaikum. Can you hear me? Can you hear me? Uh, I'm sorry because of my late. Unfortunately, I cannot connect to Adobe Connect. Okay, so this is the reason of my late. Uh, I hope you are well. And okay, today is the next session of the advanced distributed systems. Sorry, advanced database. Um, okay. Uh, can you hear me clearly? It's clear. My voice is clear for you. Okay. Thank you. Today firstly I'm going to talk about the replication logs implementation. Uh, I think this is the final topic that I talked about it in the previous session. And yes, there are some methods to implement replication logs. Uh, uh, Yes, using a statement-based replication, there are some challenges to use this method. It's not good because uh, because of using some deterministic function, a statement, okay, and other reasons. This method is not good. Um and after that, I talk about the right-ahead lock shipping or WAA shipping. I say you that this technique is very related to the hardware, and because in these techniques, um, the some bytes were changed in which in this block this information these details copy in the replication logs and sent to the other uh, sent to other followers. Okay, let me. Okay, another technique is using logical logs implementation. Uh, I say you that the logical information about the chains of the database is created by this method. I refer to the figure, to the specific figure in the first of these slides, and talk about this. Um, you can see one example of using this technique in, for example, I think, uh, yes, this is a logical data for data change. You can see some features, some values related to the features, and this information is gathered to one uh, file and send this information sent to the followers. Okay, uh, I talk about these also in the previous session. Okay, we can come back to the this slide. And another method is using trigger-based replication. This technique is more flexible. Um, in this technique, a specific method of database, which is trigger, is used for replication. Like the trigger is uh, a process of database uh, when uh, uh, when some data are changed in database, uh, the trigger can active. For example, when the new rows are added to the database, the trigger can active, and okay, they can send immediately the information uh, to the followers, or when some data, some records are omitted from the database, again the trigger can uh, active. And also when we want to update some information, some records, some data in the database, again the trigger can active. um, okay, this is another technique, but firstly, you should know what is the trigger and how we can write the trigger in database. This topic is related to the um, relational database and the principle of database, which you learn them in the previous segment. Not it's not related to the advanced database. But this technique uh, can cause more overhead uh, for the system. Okay, okay. This is another topic that I'm going to talk about. This replication lag. Replication lag is the delay between a write happening on the leader and the reflected on the followers. It, it, it is called it is called replication lag. Again, this is the delay between a write happening on the leader and being reflected on the followers. Uh, this replication lag is depend to the software, to the to the method which is implemented for to send the replication logs, and also it's depend to the network and to the distance between the matchings. Okay, some characteristics of the database, advanced database, are important to calculate the delay between the write happening on the leader and be reflected on followers. Alaykum assalam, Asir. Um, we know that the followers will eventually catch up and become consistent with the leader, but there is a replication lag between the leader and the followers, and there is a replication lags to have consistent followers. Okay, we know that eventual consistency happening after some minutes, after some seconds, after some moments. But we want to have a short replication lag. Short replication lag. Um, okay, because in this period of time, in the replication lag, when a client wants to see wants to get the information of the followers, okay, it's possible that the client receive the outdated information, when the clients wants to get the information in the replication in this time, uh, in the replication lag, uh, when the follower uh, is not updated, uh, and is not when the follower has not up-to-date information, the client, the user sent a request to see to get information, but unfortunately in this situation, in this state, the client get uh, outdated information. Okay, so in this uh, notation, you can see that see outdated information when reads from an asynchronous follower if the follower has fallen behind. Uh, we know that this is a temporary state because the consistency happen eventually. And we know that this is the temporary state, but it's important that the followers will eventually catch up and become consistent with the leader. We know the followers will eventually catch up and become consistent with leader, but there is a delay, there is a distance um, between the leader and asynchronous follower. Okay, we can highlight three examples of problem for eventual lag. Uh, uh, First, reading your own right when a client update its information, but when when the client wants to get its own right, uh, it's possible that um, clients see outdated information. Uh, Another example is monotony read. I'm going to talk about these examples and consistent prefix reads. These are some um, examples that I'm going to talk about them. Consistency does it, Omar consistency does it means that the followers synchronize with the leaders? Yes, yes, Omar, it's correct. It's correct. We know the consistent. It's mean that uh, the leader and all followers should have the same data, the same information. Uh, okay. The first example is reading your own right. Okay, one example. I see you. I'm going to talk to say one example. For example, when I'm in Imam Riza University, I connected to the uh, um, to for example to my portal, and and I change some information uh, about myself, and I'm uh, after some minutes, after some time, uh, I leave the university and I'm in car. Uh, I decide to connect to the university, to the portal university with mobile, not uh, by using uh, um, the network of university. I use the mobile, and I'm going to see my latest information and my latest uh, data, which updated by me uh, uh, some minutes ago. And unfortunately, it's possible that I don't see the latest information, and I see the out outdated information. It's possible because in the first state, I connect to the portal by the university network, and it's possible that for example, I connected to the leader, and when uh, and the second state, when I'm in car, it's possible that I connected to one follower, one asynchronous follower, and the asynchronous follower doesn't get the latest information from the leader. Okay, so in the first state, I'm connected to the leader, and okay, I can see the latest information. But in another state, in the second state, uh, I uh, I have connected to uh, to the asynchronous follower, and unfortunately, I see the outdated information. Uh, okay, is it clear for you? Can you understand me? Um, Mustafa, leader and followers are some matchings. Some matchings, uh, both leader and followers uh, store the data, store the same data. But each write query sent to the leader, and the leader is responsible to um, uh, create a replication log and send this replication log, which consists of the data change, uh, sent to the followers. Uh, okay, but there is a replication lag. There is a replication lag between the leader and followers, asynchronous followers, because we have two types of followers: synchronous followers and asynchronous followers. There is a replication lag between the between the leader and asynchronous followers. Okay, so in the first step, when I'm in university, I connected to for example, to leader or some synchronous follower. When I leave the university and I'm in car, uh, okay, it's possible that I connected to the asynchronous follower, and because of the replication lag, this asynchronous follower that I'm connected to it, uh, these uh, these followers, this follower has not up-to-date information, and okay, so I cannot see its own data, its own up-to-date data. Okay, is it clear? Okay? Thank you. You submit some data and then view what you have submitted. It's about the reading your own data. You submit some data and then view what you have submitted. New data is submitted to the leader. Okay, we know that new data is submitted to the leader. However, the user can view the data. The user can view the data from the follower, and the data may not reach the replica. May not reach the replica, which is asynchronous followers. Okay, so we need to read after right consistency. We need to read after right consistency because we submit some data, and after that, we are going to see what we have submitted. But and okay, it is called read after right consistency, but it's possible that we connect to the on asynchronous follower, and unfortunately you see uh, outdated data, uh, not up to date information. Again, we can see this topic in this figure. Uh, the user 1234 wants to insert new Omar say that each page can be shown to us as a scheme written on the page so that the idea can be better communicated. Okay, Omar. And Nazar say this means that the display of data by the user can be on the updated version, on the non-updated version. Uh, okay, in this figure we can get the concept of reading your own right with an example, with a good example. Okay, please consider this figure. Okay, Nazar, can you hear me? Can you hear me? Okay, thank you. Uh, the user uh, the user 1234 wants to insert s- uh, okay, one record uh, to the comments table. You know, this is the comments is the name of table, and these features of the table, author, reply to a message. Okay, we are going to insert the new record in this table by using this update, this insert information, this insert query. Okay, so the user 1234 wants to insert the new row in the comment table. Okay, this query is sent to the leader because this is the right query. It's the right query. Uh, okay, this query, this right query is sent to the leader, and leader uh, send okay, commit this query, and also send the replication log, the replication chain, sorry, the replication change to the uh, follower 1 and follower 2. Okay, and these two followers, both followers are asynchronous follower, and the leader doesn't wait to get okay from these followers. Uh, the leader perform the query and send the okay to the user. Okay, so the user uh, get its acknowledge its own acknowledge, and okay, after some time, the user wants to see the latest row, the latest record, the latest information which is inserted uh, by himself. Okay, so this query is sent from user 1234 to one follower. This is the select. It's the select query. Select a star from comments where reply to 55555. Uh, but this is this is the select query. This is the read query. This is the read query, and we know that the read query should send to any followers. This request is sent to follower 2, and follower 2 uh, has non-updated information, non-updated uh, data, because the this message from the leader, which is about to the user, received by the follower to in this time, and the user wants to get the latest information at this time, previous the previous uh, uh, the next the this time. Okay, so when this query is sent from user to the follower uh, has the follower not uh, has not updated information, and okay, so no result. There is no result for the user, and the user cannot reading your own right. The user cannot reading your own right, because again in this figure it is clear that the latest information received by the follower to uh, after after uh, this read query. Is it clear for you or not? Is it clear for you? A user make a write followed by a read from a stale replica. To prevent this anomaly, we need read after write consistency. Sorry, uh, can you hear me? Okay, if you hear me, this figure is clear for you. Can you understand the concept of reading your own write? Yes, Mohammed Nazar. Yes, Nazar. Uh, Inshallah, I will upload it. Uh, I will upload it, this information, this uh, concept, inshallah, in this week. In this week, inshallah, I will upload it. The file. Nazar, you can download it from the Dersa, inshallah. Inshallah, in this week. Okay. We need read after write consistency. How to implement read after write consistency? There are some methods. There are some methods. First, when reading something that the user may have modified, read it from the leader. Read it from the leader. Okay, um, according to the replication lag, when the user wants to read uh, its own its own information, its own right, um, in the time of replication lag. uh, this uh, this request should send to the leader, not to the asynchronous follower. This request should send to a leader, not to uh, uh, asynchronous follower. This is one technique. Okay, Muhammad Jafar. Okay, I say you that I'm going to upload the MP4 file, or I don't know, the video file, inshallah, the video file of this concept in this week, and I did not I did not upload this video file up to now. Okay, so uh, please wait. In this week, I'm going to upload this video file. Okay, Muhammad Jafar, is it clear? You're welcome, Muhammad. Um, Sorry, because of this delay, this uh, weak internet connection, I'm going to change my internet connection. Okay, so please let me for 5 minutes, inshallah. I'm going to change my internet connection. Okay, because some students that say they can hear me clear, but the image is not clear for you. Okay, so I'm going to change my internet connection. And thank you. Okay, please check again. Please check again my voice and the picture. Is it clear for you? Okay. Uh, okay. So the first method to implement read after write consistency is using okay the in the replication lag uh, in this period of time, the read information, also the read query sent to the leader or synchronous follower instead of uh, asynchronous follower. Okay, so read the users on profile from the leader. Okay, there are some criteria to decide whether to read from the leader. Okay, uh, so we need some criteria to decide whether to read from the leader or follower. In this technique, we need to track the time of the last update, and make our read from the leader, Okay, according to the last update. If the last update uh, is before uh, the time that's the client submits uh, the right query. Okay, if this time is if the last update is before the time of uh, the time that client updates information. Okay, this in this time uh, the read query should send to leader, not to follower. And another technique is cross-device read after write consistency. Uh, in this technique, cross device after after uh, classify read after write consistency. In this technique, for each user, a specific data center is selected, is specified, um, and is according to the to the user. For example, when we have, for example, three data centers, data center 1, data center 2, and data center 3. For example, the data center 1 is selected for the user 1, 2, 3, 4. Okay, so uh, the data center 1, 2, 3, 4 should have uh, the update information from this user, from the user 1, 2, 3, 4. And in another example, when the data center 2 is selected for the user 2, 3, 4, 5. Okay, data center 4 is selected for user 2, 3 for the client, 2, 3, 4, 5. Okay, so when we want to see the latest information from the data from the user 1 2 3 4, this read query should send to the uh, data center 1, and if we want to see the latest information from the user 2 3 4 5, this query this read query should send to data center 2. Okay, route requests from all of a user's devices to the same data center, Uh, okay. Nazar, can you hear me? You right? No, so you cannot hear me? Adobe connection. Show me that my internet connection is good. It's excellent. Connection status is excellent. It's right. Okay, okay. Uh, Thank you. Um, uh, okay. I changed the slide and I'm going to talk about another um example of challenge which caused by replication lag. I'm talking about the monitor read. Uh, Omar asked, is there a single or multiple data center to receive requests? Omar, in this concept and in this class, uh, we are we are going to talk about the uh, distributed uh, database. Okay, so there are some data centers in distributed database. Don't forget there are some data center. Uh, so uh, so because of this reason, we have multiple data centers. So for each user, one data center is specified, is selected, and okay, the read after write request should send to only one data center, which is specified for any user, and we we accept that see the updated information from the selected from the specified data set. Mohammed Jafar said the internet is in Iraq is bad. Okay, it is unfortunately. What is the benefit of follower one and follower two? The follower, there is not any benefit between the follower one and follower two. It's depend to their status. And for example, when the follower, for example, when the follower one is closer to the leader, okay, so it's possible that the follower one uh, gets information sooner that follower two. Uh, okay, so there is not benefits between the follower one and follower two, but it's upon to the status, it's upon to the network, it's upon to any status of which can change in each time. Okay, I'm going to talk about another example and another challenge. It's called monotonic read. Monotonic read. A user first read from a okay. In this example, the user wants to 1, 2, 3, 4 wants to insert uh, a new row into the comments table. Okay, so this is the right query, and this right query is sent to the leader. Mohammed Jafar asked, does this explanation represent how users are sequenced? No, this is different, Mohammed. The challenge of replication is related to the network, is related to the bandwidth, is related to the links between the matchings. Okay, and in the network, and these metrics can change over time, not to the user, especially it's not the overall, I can say it's not to the users, and it's more appropriate to, it's more dependent uh, to the network. Nazar asked, Doctor, does this mean that any request from access to user one data, for example, from any other user sent to the same data center of user one? Yes, but if we want to read after write, read after write. Nazar, I talked about the read after write in the previous slides. Okay, read after write is related to one user, not to other users. Okay, when I want my latest information. Okay, so it's possible that I commit, I send. I updated my information. I updated my information. Okay, and after that, I get decision uh, see to see the latest information of myself. Okay, so this in this situation, mm, the read query the read query of myself, this query should send to the specific data center. For example, if data center one is selected for me, okay, when I want to see an up-to-date information from myself, this query should send to the data center one. But any other users, for example, you and other classmates, other your classmates, when you want to see my latest information, it's not called the read after write because you want to see the up-to-date information of another user, not yourself. So this is another challenge. Once you wants to see the latest information of another user, it is another challenge. Welcome, Nazar. Okay, another example is monotonic read. Okay, so please concentrate into this slide. The user 1, 2, 3, 4 send this write query to the leader, and okay, this query is performed on the leader, and the okay is sent to the user 1, 2, 3, 4. Also, we know that the leader is responsible to send this uh, change this uh, change log to all followers, to follower 1 and follower 2. The follower on the follower 1 uh, get this change log sooner than follower 2 because this message is sent to the follower 1 and at this time and uh, received by follower 2 at this time. Another user 2, 3, 4, 5 one wants to uh, get the latest information and wants to read this uh, this raw record, this data. Okay, so this read query is sent from user 2, 3, 4, 5. This query is sent from user 2, 3, 4, 5 to the follower 1. And in this figure, it's clear that follower 1 has updated information. Okay, one result return to the user 2, 3, 4, 5. Okay, because the follower 1 has updated information. User 2, 3, 4, 5 decide to get uh, again decide to uh, send this query to the follower 2 because the user 2, 3, 4, 5 wants to execute again this query. You can see these are the same. Select a star from comments where reply to 55555, and again select a star from comments where reply to 55555. These are the same. But at first, this read query is sent to the follower 1, and in another state, this query is sent to the follower 2. The follower 1, which has the latest information, updated information uh, return one result, but the follower to the follower to which has not the updated information, updated data, cannot return any result, cannot return any result. Okay, so no result is sent from follower to a user was to 2, 3, 4, 5. Okay, so uh, for a for a one request, unfortunately, we can see the user receive two two different results, and it's not consistency because because we need to receive the same results from uh, the same result from a unique request. It's called monotonic read. It's called monotonic read. Uh, okay, a user first read from a fresh replica. It's the follower one is fresh replica. Then from a stale replica, the follower two is a stale replica. Time appears to go backward. To prevent this anomaly, we need monotonic read. We need monotonic read. Make sure that user read from the same replica. Okay, this is the technique. This is the technique for this challenge. In this technique, all the both the unique request uh, should send to the one follower, not two different followers. This is the method which is presented for monotonic read. Okay, can you get it? Okay, thank you. And another challenge is consistent prefix reads. Consistent prefix reads. I'm going to talk about the violation of causality. Consistent prefix reads. Okay, I'm going to talk about a violation of causality. Uh, okay, in this figure, uh, we can see that the Mr. Pooh's and Mrs. Cake wants to uh, uh, I'm sorry, let me uh, let me 1 minute, sorry. Uh, Mr. Prunes and Mrs. Cake uh, are using a social network application, for example, and uh, they are going to talk about okay, something. For example, they are going to talk about uh, okay, okay. Uh, this is heavy loaded application, and so the data of this application can partition into can separated into two partitions. Separated, it can separate into two partitions, partition one and partition two. Again, uh, Mr. Poons and Mrs. Cake wants to uh, talk about okay, a specific topic. I don't know. It's not important, and they are going to use a social network application, and because of heavy load, the data is separated between two matchings, and the partition one uh, can store to this follower, and the partition 2 can store in the follower 2, in the another follower. Okay, so I'm sorry, my internet connection cut off. Uh, I return. Okay. I talk about this example. I say you that because of the uh, uh, because of the huge data, the data is separated into two partition, and partition 1 and partition 2. Okay, so we have two leader for partition 1 and partition 2, and also two follower for partition 1 and partition 2. Uh, uh, you know, the uh, the horizontal dimension show the time. Okay, so first, Mr. Pools send a message, which is a from Mrs. Cake. He asked, "How far into the future can you see Mrs. Cake?" This message is stored in partition 1 leader, and also we know the leader to should send this uh, message to the follower, and this follower is the follower of the partition 1 leader. Okay, uh, the leader send this uh, change log to the follower, and the change log is received by the partition 1 follower at this time. Okay, we can see it. Also, this message is sent to the Mrs. Cake, and Mrs. Cake reply this question, and Mrs. Cake uh, the response of Mrs. Cake is about 10 seconds, usually Mrs. Spoons. Okay, this is the answer of Mrs. Cake to this question. And this answer is sent to the leader 2, and stored in the partition 2. Okay, it's possible that some message is stored in the leader 1, and other message is stored on the leader 2. Okay, so this response is sent to the leader 2, and also leader 2 should send this change uh, to the follower of its of which is called partition 2 followers, because we know these matchings is responsible to store the information of partition 2. But we can see the follower of partition 2 uh, is get the latest information sooner than the follower of partition 1. In this figure it's clear, yes. The follower of partition 2 is get the latest information sooner than the follower of partition 1. And there is an observer in this figure. The observer wants to see all information. Okay, so the observer sent the request to get the latest information from both followers. And unfortunately, since the follower of partition 2 get the latest information sooner that the follower of partition 1, this message first this message is sent to the observer, and after that this message is sent from the follower of partition 1 to to the observer. And so the observer see the answer, and after that he see uh, the question. Okay, see the answer before the question. Okay, and this is a violation, and it's called the violation of causality. If some partitions are replicated slower than others, an observer may see the answer before they see the question, and it's called violation of causality. It's another example in another challenge when which comes from the replication lag. We can see the replication lag between the follower of partition 1 and the leader of partition 1 is too big in comparison with the replication lag between the follower of partition 2 and the leader of partition 2. Can you understand? Is it clear for you? Okay, thank you so much. Thank you because of consideration, participating. Um, okay, if any question, okay, no, no. Please see this slide as the final slide of this session. In many distributed databases, different partitions operate independently, yes, such as previous example. There is no global order of writes, and we need to use an algorithm that explicitly keep track of causal dependency. Okay, thank you so much, and this session is finished now. And if you any question, I'm hearing. If you have not any question, okay, we can finish the class now. You're welcome. Thank you too. Have a good day. Bye for now. Thank you so much. Bye for now.